What is the average power dissipated by a 50 ohm resistive load during one complete RF cycle having a peak voltage of 35 volts? Is it 12.2 watts, 9.9 watts, 24.5 watts, or 16 watts? Answer A, 12.2 watts. What determines the peak envelope power to average power ratio of a single sideband phone signal? A, the frequency of the modulating signal. B, the characteristics of the modulating signal. C, the degree of carrier suppression. Or D, the amplifier gain. Answer B, the characteristics of the modulating signal. Electromagnetic fields. Electromagnetic fields are made up of magnetic lines of force and electric lines of force at right angles to one another. Here's another illustration of electromagnetic fields. What is an electromagnetic wave? A, alternating currents in the core of an electromagnet. B, a wave consisting of two electric fields at right angles to each other. C, a wave consisting of an electric field and a magnetic field oscillating at right angles to each other. Or D, a wave consisting of two magnetic fields at right angles to each other. The answer is C, a wave consisting of an electric field and a magnetic field oscillating at right angles to each other. And now let's look at test equipment. The Humboldt digital voltmeter is the single instrument that I use the most frequently in my ham shack. Here's a picture of an older vacuum tube voltmeter multimeter. A grid dip meter is handy for measuring resonance. This MFJ antenna analyzer can also be used as a grid dip meter. This impedance bridge can be used to determine the value of an unknown component. A frequency counter is another useful instrument. An oscilloscope is particularly handy for being able to see what a signal looks like in the time domain. A spectrum analyzer shows us what the signal looks like in the frequency domain. Which of the following is a characteristic of a good DC voltmeter? A, high reluctance input. B, low reluctance input. C, high impedance input. D, low impedance input. The answer is C, high input impedance, so that it does not unduly load down the circuit being measured. If a frequency counter with a specified accuracy of plus or minus 1 part per million reads 146,520,000 hertz, what is the most the actual signal measured could differ from the reading? Answer C, 146.52 hertz. Which of these instruments could be used for detailed analysis of digital signals? A dip meter, an oscilloscope, an ohm meter, or a Q meter? Answer B, the trusty oscilloscope. Which of the following procedures is an important precaution to follow when connecting a spectrum analyzer to a transmitter output? A, use high-quality double-shielded coax cables to reduce signal losses. B, attenuate the transmitter output going to the spectrum analyzer. C, match the antenna to the load. D, all these choices are correct. The answer is B, attenuate the transmitter output going to the spectrum analyzer so that you don't burn out the spectrum analyzer input. And now for modulation. There are a number of forms of common modulation, including unmodulated carrier, Morse code telephony, double sideband full carrier amplitude modulated telephony, amplitude modulated single sideband suppressed carrier telephony, and frequency modulated telephony. With frequency modulation, the unmodulated carrier you see at the top of the screen is modulated by a lower frequency signal, such as coming from a microphone, to produce the waveform that you see at the bottom. With frequency modulation, the deviation ratio is equal to the peak deviation in hertz divided by the maximum modulating frequency in hertz. With pulse width modulation, the width of the output pulses is a function of the area, the energy trapped between the information waveform and the sampling waveform. With pulse amplitude modulation, the information waveform is determining the amplitude of the sampling waveform. When using a pulse width modulation system, why is the transmitter's peak power greater than its average power? A, the signal duty cycle is less than 100%. B, the signal reaches peak amplitude only when voice modulated. C, the signal reaches peak amplitude only when voltage spikes are generated within the modulator. Or D, the signal reaches peak amplitude only when the pulses are also amplitude modulated. And now interference and noise. Intermodulation, or intermod as it's known, can occur when RF signals from several signals add or subtract together. The most common form of static noise is caused by the buildup of static electricity in the atmosphere, mostly during thunderstorms. Electrical line noise can be particularly troublesome. It can cover up all but the very strongest of signals. Arc welding in your area can be particularly troublesome. A brute force AC line filter in series with the power leads will help block the noise from being conducted along the power wiring. Here is an example of a commercially made AC line noise suppressor. Here are a couple of instruments that are very useful for helping to track down the source of AC line noise. Automotive noise isn't much of a problem at VHF and UHF, but it can be a huge problem on HF. Ignition noise and generator noise are frequently the culprits. How can noise from an electric motor be suppressed? A, by installing a high-pass filter in series with the motor's power leads. B, by installing a brute force AC line filter in series with the motor leads. C, by installing a bypass capacitor in series with the motor leads. Or D, by using a ground fault circuit interrupter in the circuit used to power the motor. The answer is B, by installing a brute force AC line filter in series with the motor leads.